Looking another problem of related to mechanism. This time we have propanone adding to bromine to give us two new compounds in acidic solution. So the acid, hydrochloric or sulfuric acid, is our catalyst, but its concentration also can affect the rate of reaction. So the experiments were conducted, 5 different trials. The rates are given, and we are looking at the changes of concentration versus rates. So the first one I want to go after is by inspection. We are going to compare reaction 2 compared to reaction 1. You see the rate, the concentration of propanone is doubled. The rate has doubled. So what we can say is rate equals K times propanone first order. Because you double the concentration, the rate doubles. To look at the effect of bromine, maybe we are going to look at experiment 1 and 3, because propanone is constant, bromine is doubled, hydrogen is constant, and you see the rate doesn't change. So this will say with respect to bromine, it's 0 order. So concentration of bromine has no effect on the rate. Finally, to look at the effect of hydrogen, so we are going to look at experiment 4 versus experiment 1. The two reactants are constant. Hydrogen ion is doubled. The rate is also doubled. So that's also first order with respect to hydrogen. So rate overall order is 2, is affected by concentration of propanone and hydrogen. Now to answer this, somebody has to come up with a mechanism. And when they do that, our job is to see if the mechanism is good enough or to reject it. So this is what a mechanism looks like that was proposed. There are 3 steps. Now let's just see if the first criteria is satisfied. Let's add them up and see if we get overall order. Hydrogen is introduced in one reaction and is consumed in the next one, so this is our catalyst. That's good enough. We cancel that out. Now this is intermediate. It comes to life in one reaction and it's used up in the next reaction, so this is one intermediate. We cross them out. There is another intermediate too. Second step produces this. The third step consumes this. So that's intermediate. So let's see what we have left. I have propanone left, CH3COCH3, plus bromine in the last step, giving me the product that I see in my overall reaction, plus HBr. So the first criteria is good. Now, it's up to us to decide which step is slow. So I'm going to write the rate for all 3 steps. The first one is K. It could be K1 times propanone raised to power of its coefficient, which is always 1 for elementary steps, and H to power 1. The second one has rate equals K2 times unimolecular single molecule breaking into 2 power 1, and finally the last one has a bimolecular, which is CH2 double bond COH CH3 times bromine. Since I don't have bromine in any of them, this should be fast. Since I see my first reaction, first step, same as my experimental, I'm going to say this should be my rate determining step. So this reaction is RDS. It's the slow one. It's the one with large or largest EA, and it has the smallest K, just for sake of knowing what's happening. So the first step is slow. My steps add up to be overall reaction. So this is a good mechanism, and we accept it.